Hello everyone. So now we have finished the simulation. First we'll check the residual plots. So we can see at the end of the simulation, um, when we enlarge the residual plots, the continuity x momentum and y momentum are all below 10 to the minus 6. And the energy line is below 10 to the minus 8 at the end. So we consider this as converged. And next we can check the mass flow average monitor plot, and you can see that it's pretty steady at the last couple steps. If we want to know the value of the mass flow rate, we can just double click the mass flow average one over here, and it will show the mass flow rate at the end of the simulation domain. Now we'll go to the scalar scene. So this is the scalar scene, and you can see how the temperature varies in the simulation domain, and also you can see the scale. The legend is from 300 to 346.87 K. And these values mean the temperature inside each cell, which means that the temperature in each single mesh. So you can see that the red over here, it should be close to 346.87 K, and in these blue section it will be 300 K. And now we will change the contour style from automatic to smooth filled. So in this case, we will get a smoother contour over here, and also we'll see the legend will change to 300K to 350K. And that because in this contour style, it will show not only the temperature inside the mesh, but also the temperature at the boundaries. So that's why we have the temperature at 350K. So now we'll try to see the profiles inside this simulation domain. First, we'll create a line from the beginning to the end and very close to one of the fin walls. So I'll right click on the right part and select probe and create a line probe. Now you can see there's a preview over here, which this is the starting end, and this is the point 2. So I'll change point 1 to 0 millimeter in X direction and 54 mm in Y directions. So we can see the change in the preview. And for point 2, I'll use 290 mm and change Y to 54 mm. And also I would like to change the resolution to 50. So it means that there will be 50 points on this line. I'll also select no displayer and select create. And now I'll close this. I'll go to plots, right click, and create a new XY plot. So first, I'll select the locations in parts and select the line probe over here and click OK. And the X type, that will be the bottom axis, and the direction is in X direction, which shows in 1 over here. That's the X direction, so we don't have to change that. And in Y types, we're going to select the scalar function, and we'll select temperature and click OK. So now you can see all these points over here, and there should be 50 points because the resolution we set earlier were 50. And also we can connect these dots with the line by selecting the line style and choose this one. So there will be a solid line connecting all the dots. And just keep in mind that these values should be the values next to the wall. So it's not showing 350K, it's showing some other values. So if we change, and if we click the smooth values, it will show the temperature at the boundary, which should be 350K. I can change the scale of y-axis from here. Left axis, I will set the maximum to 350, so that you can see that this is the temperature of the boundary. So if I unclick smooth values, it just shows the temperature at each cell next to the boundary. And next, I'm going to create 3 line probes to see the profiles at in between the plates. So I'm going to create 3 lines. Also, new part, probe, and line probe. First, I'll create a line 10 millimeters away from the beginning of the fins. So that will be 60 mm, since there's a 10 millimeter in the inlet section, 50 millimeters in the inlet section. And Y will be 38 mm. So you can see the point 1 is over here. And point 2 will be 60 millimeters as well, and 54 millimeters. So that this will be the first line. I'll select no display and create and close. And now you can see the right part is a line probe 2. And I will right click and rename it to 10 mm because it's 10 mm away from the beginning of the fin. So next I'll create another line probe, and this time it will be 95 mm and 38 mm and 95 mm and 54 mm, and also select no display. Then you can see that this is the second line, and I'll click create and close. So the second line, I'll rename it to 45 mm, and I'll create the third line. So X will be 130 mm and Y will be 38 mm, and at point 2 X will be 130 mm and Y will be 54 mm, and also no display. And you can see this is the location of the third line. I'll click create and close, and I'll rename it this line probe to 80 millimeter. So now I'm going to create another XY plot. So right click and select new plot and XY plot. And because we want to look at the profile that varies along the Y direction, so I will change the X type over here from 100 to 010, and also we'll make the X axis at the left axis. And in the Y type, we'll have to select the scalar function, and we will check the velocity first, and we'll select the velocity magnitude and click OK. And we also have to set where we want to see the profiles, so that will be we'll select part and select 10 millimeters, 50, 45 millimeters, and 80 millimeters, and click OK. So, we also have to change the Y type 1 from left axis to bottom axis. So now you can see these dots. And similarly, we can also select the line style just to connect all of the dots. And you can see that these lines looks like some zigzag lines, and that's because they're showing the values in the cells. So we can also make the profiles to be smoother. So we'll go to Y type 1 and click on smooth values. Then you can see the program will interpolate some of the values and give you the smooth values. And you can see the red one, that's the line probe at 10 millimeter, and the green one is the line probe at 45 millimeters, and the blue one is the line probe at 80 millimeters. So the results should meet our expectations because it becomes more and more developed. So you can see in the red lines, the velocity is flatter, and when it is at the 80 millimeters, the lines becomes more parabolic. And also we can see the temperature profiles at these three lines. So all we have to do is to change the scalar function from velocity magnitude to temperature. And click OK. So now we can see that the profiles becomes more and more developed as it goes from 10 millimeters to 80 millimeters. The red one is still the 10 millimeters away from the beginning of the fin, and 80 millimeters is the blue one. You can see that it's more parabolic right now. So this will be the end of the demonstration.